Now we're going to use the laws of logarithms to expand each expression. So when we're talking about expanding logs, we're going to be starting with one log, and then we're going to break it up into adding and subtracting with different logs. So we have log of 5x cubed y. So since the 5, the x cubed, and the y are all being multiplied together, I'm going to break this up into addition, since addition and multiplication go hand in hand. So this is going to be log of 5 plus log of x cubed plus log of y. Now, one of the properties was that we can't have exponents. The exponents go down in front. So log of 5 is fine the way it is. We're going to change the next one. The 3 is going to come down. So it's going to be 3 log of x. And then the last one is fine the way it is, log of y. Now in the second one, it uses an ln, which is a natural log. It works the same exact way. Just instead of writing the word log, we're going to write ln. So we have division going on. So division goes hand in hand with subtraction. So we're going to take the top, so ln of 3x minus 5, minus ln of 7. Now we can't have radicals when we're expanding. So we're going to first rewrite this as 3x minus 5 to the 1/2. And then we're going to just keep ln of 7 the same. And then the exponent now must go in front. So we're going to have 1/2 ln of 3x minus 5 minus ln of 7. And now this is fully expanded. So in fully expanded form, you don't have any exponents, you don't have any radicals, you don't have any multiplication or division. You're going to have adding and subtracting. So let's look at number 3. So we have log of the square root of y over x to the 4th cubed root of z. So we have division going on. So we're going to take log of the square root of y, and we're going to subtract the bottom. So log of x to the 4th cubed root of z. Now, we just want to be careful here. Anything that's going to be in the denominator is going to be subtraction. So even though the x to the 4th and the cubed root of z are being multiplied together, and you would add them, when we subtract, we're subtracting the entire bottom. So if you want to make it into addition, that's fine, but then you're going to have to distribute your negative. So what I mean by that is I'm going to keep this as log, and I'm going to change this to y to the 1/2. And then when I subtract, this is going to be log to the x to the 4th plus log the cubed root of z. So I'm putting a plus in there, but because it's in parentheses and I'm subtracting the entire thing, it's going to end up being a negative log of cubed root of z. Okay, so the thing to just remember is that if it's in the top, it's going to be a plus. It's going to be a positive. If it's in the bottom, it's going to be a negative. So let's kind of finish simplifying this. So what I'm going to do is I'm going to bring the 1/2 in front. So I have 1/2 log of y minus, I'm going to bring the 4 in front. So I have 4 log of x. And then since I'm distributing this negative to both, this is going to be a minus. And then the cube root of z, I'm just going to change it up here real quick. The cube root of z is just going to be z to the 1/3. So I'm going to bring that exponent in front, and then I have log z. So 1/2 log of y minus 4 log of x minus 1/3 log of z. Okay, and now in the last one, we have division going on. So we're going to subtract. So we're going to write the top first. So we have log of x cubed square root of y minus the log of z squared. So what we're going to do now is, since I have multiplication happening, the x cubed and the square root of y, I'm going to break those up into addition. So log of x cubed plus log of the square root of y minus log of z squared. Okay, so I'm just going to bring the 3 in front. So this is 3 log x. Then the square root of y is really y to the 1/2. So I'm going to bring the 1/2 in front and write this as log of y. And then the 2, that's my exponent, is going to go in front, and I have log of z. Now this is fully expanded.